Hey physics friends, and welcome to video 3.3, part 1. And this, I'm going to intro something to you guys. We're going to be changing between position versus time, velocity versus time, and acceleration versus time. And so I've got 3 graphs up here, and I've got a very special device. It's sitting on the floor. It looks like this. And it's, I'm going to hit play on this, and I want you to listen. Can you hear that? It's sonar. It's sending out a click, and it listens for the reflection off of an object, and from the whole velocity equals distance over time, because the speed of sound is 343 meters a second, it knows how far away you are. So it compiles all the data over here, and then it graphs it over there. So I can look at position. I'll point it at the back wall rack here. Watch this. Let's see. If I move it farther away, closer, farther away, closer, I can do all this graphing, position, velocity, and acceleration. And what I want to do, I have a ball, basketball. I'm going to put this on the ground. I'm going to throw my basketball up in the air and then catch it. So it's going to take some data. It's just kind of neat, and we'll look at it. Let's see if we can get it to work. So I'm going to clear all my data here. Start over. And let's see if we can get ourselves some good data. Oh, first try, baby. That was awesome. What I'm really looking at is this, from here to here. Me throwing it up into the air. So you can see from my position versus time graph, it goes up into the air. It stops at the top, and it falls back down to the ground. Makes a perfect, well, in the biz, we call this a parabola. So the ball's going up, stops, the ball's coming back down. And you'll see over here, I've got a really nice little velocity versus time graph. And I've got a really great little acceleration versus time graph here. And there's a couple things I want to talk to you about this, but I'm going to pause for just a moment. So there's a lot to unpack here, and what I really want to focus on is just a couple of things that we've talked about in the past chapter when we have a position versus time graph. So for instance, some of the things I want to talk about. Right here, this spot at the very top, it stops, right? The tangent line at that point, this point, the velocity is equal to 0. And we talked about this. If you have a spot, the slope of the tangent line is the velocity. So at the very top, when you throw something in the air, it stops. And if you look down here, the velocity right there is equal to 0. Look over here. If you find that, the slope of that line looks like it's probably around 4. And then if you look down here, there's the velocity. The velocity is 4. And over here, the slope is probably around -4. So if you go down here, that's why the velocity is -4. And then some of the things we talked about with velocity and acceleration. Remember that acceleration is your change in velocity over your change in time. So you can see here on this graph that my velocity is changing at a constant rate. My velocity is changing at a constant rate. So you'll see here that my acceleration is constant. Every second that goes by, my velocity changes a certain amount. Every second that goes by, my velocity changes a certain amount. Every second that goes by, it changes a certain amount. It's a uniform change in velocity. So what's really important that I wanted to show you is that when you have a diagonal line, you'll see that my acceleration is a horizontal line. And you've got some stuff happening over here. This is me throwing the ball up in the air, and this is me catching the ball. So you're seeing a little bit of noise, but the only thing I really want you to focus on is this section right in here, where the ball is in the air. So as we move forward, I wanted you guys to see this, and I wanted like the data to pop up for you so you could see it kind of in your own eyes, that when you throw something up in the air, follows that parabolic path. At the very top, it stops, and that's why my velocity is 0. Something else that's interesting is even though it stops at the very top, my acceleration is still negative 9.8. We'll learn this a little bit later, but this is what planet Earth does. When you drop a ball, every second that goes by, it gets 9.8 meters per second faster. So after 1 second, it's going 9.8, and after 2 seconds, it's going 19.6, and after 3 seconds, like around 30, it keeps getting faster, faster, faster. In reality, we have air resistance that's going to prevent us from just going to infinity as far as our speed is concerned. But it's really interesting to note that just because I'm stopped at the very top, I am still accelerating. You know, I go from 4 meters per second down to 0. And then I go from 0 down to negative 4. My velocity is changing at a uniform rate. So I wanted you guys to see this. As we start changing, we're going to start going between the graphs. Like I'm going to give you a position versus time graph, and you're going to have to make the other two. If I give you an acceleration versus time graph, you'll make the other two. If you happen to be in calculus, I know that's not many of you, but sometimes I have a couple of people who are in like AP Calc, or maybe even further, like you're in Calc 2 or Calc 1 at the university. But what this is taking the derivative. Going from this graph, your position versus time graph, down to, it's the derivative. It's just the slope at any point is equal to what the velocity is. So for those of you, the slope at this point is what the velocity is. The slope at this point, that's what the velocity is. The slope at that point, that's what the velocity is. And each of these points, the slope at this point, negative 9.8. The slope at this point, negative 9.8. The slope at this point, negative 9.8. So you're using the derivative. If you want to go backwards, we call that the integral. The antiderivative, maybe those are words that you've seen. But you do the integral. The area underneath it is how much it changes. So we'll get to all of that stuff, but I wanted to give you an introduction.